Lesson 9.6 is a mix of 9.2 to 9.5. So we have the 4 conic sections just all in one section. So here's a review of the equations for all 4. And the only thing that I would change, the way we learned a parabola was x equals in the front. So I'm just going to cross this out. And then same thing for the vertical, y equals here. All right, so for number 1, they just throw an equation at you and you have to state whether it's a parabola, circle, ellipse, or hyperbola. And then you also have to write the equation in standard form and graph it. So for number 1, I see that only one variable is squared, and that's x. So anytime you only have one of them squared, it's a parabola. So I'm going to identify it first and then put it in standard form. So this is a parabola. And if you recall from 9.2, standard form for a parabola isolates the non-squared variable. So I would divide both sides by -3. And I'll move the x to the left side. So if I take y squared divided by -3, that would be -1/3 y squared. So I guess essentially, I just multiplied both sides by -1/3. All right, so we have standard form. We've identified it, so now we just have to graph it. So this has a vertex at 0, 0. And because x is isolated, I know that this opens sideways. So vertex at 0, 0. And now we do the pattern. So this would go left 1/3. So remember the normal pattern is 1, 3, 5. These will all get multiplied by 1/3. So it would be -1/3. And usually that means down, but in this case it means left because it's sideways. So -1/3, up and down 1. Then I would go -3/3 or -1. So that would mean left 1 unit and up 1. Left 1 unit and down 1 also. All right, next would be -5/3, which is the same as -1 and 2/3. So that'll put us back on a corner coordinate. So I can go left 1 and 2/3, up 1, and same thing, left 1 and 2/3 and down 1. All right, maybe I could squeeze in one more. After would be left 7/3, which is left 2 and 1/3. So from your last dot, go left 2 and 1/3 and up 1, and then left 2 and 1/3 and down 1. All right, after that would be left 3. I guess we could try to squeeze that in. Left 3, so I take 9 and multiply by -1/3. That would mean left 3 units, which is just barely off the graph. Okay, for number 2. So I know number 2 is not a parabola because they're both squared, x and y. I know it's not a hyperbola because x squared and y squared have the same sign. In a hyperbola, they would have opposite signs. So this is either a circle or an ellipse. And the way I could tell those apart, notice x squared and y squared have the same coefficient. Because they have the same coefficient, the distance that it goes up and down is going to be the same distance that it goes left and right, so that makes it a circle. Okay, I'm going to put the x's together. and leave a gap. The y squared does not have a y to the first to go with it, so we don't have to complete the square for the y. All right, so completing the square, I get a plus 9 here. So this is going to be x plus 3 squared plus y squared equals 16. They don't ask for it, but might be helpful if we write the center is negative 3, 0, and the radius is 4. So let's graph that. So we go to the center and we go up, down, left, and right 4 units. Okay, for number 3, because there is subtraction between the two squared terms, I know this is a hyperbola, so let me identify that first. This is a hyperbola because the x squared and the y squared have opposite signs. Okay, so now we have to put the equation in standard form. So I'm going to put the x's together first. Then put the y's next to each other. The constant can stay on the other side by itself. Take out a 5 for the 2x terms. So 30 divided by 5 is 6. Leave a gap. Take out a negative 6 for the y's. So y squared plus 2y. And I leave a gap. All right, let me complete the square. So for the x's, I need a plus 9. And for the y's, I need a plus 1. On the other side, I need to add 45 and subtract 6. Okay, so this is going to be 5 times x minus 3 squared minus 6 times y plus 1 squared equals 30. So we have x minus 3 squared. 5 over 30 reduces to 1 over 6. And 6 over 30 reduces to 1 over 5. Okay, so this will have a center at 3 comma negative 1. We graph that point. Now I need to make a box. So 6 is not a perfect square. So because rad 6 is between 2 and 3, I'm going to go left and right about 2.5. And because rad 5 is slightly above rad 4, and rad 4 is 2, so for rad 5, I'm going to go up and down about 2.25. All right, so then I make a box with those outside points. Then I need to draw the diagonals of the box. Those would be my asymptotes. All right, and then my hyperbola is horizontal, so I'm going to do the side. So I do the side of the box, and I aim for the asymptotes. Okay? Okay, on the back, the first 3 have the same directions as the ones we were just doing. So you might look at number 4 and think it's a hyperbola because the x squared is negative, but the y squared is positive. But remember, the x squared and the y squared need to be on the same side. So I'm going to move them to the same side. And I'll keep them in alphabetical order for now, but remember, now that we can tell it's an ellipse, the one with the bigger denominator needs to go first once we're done putting it in standard form. So first thing I have to do is divide everything by 1225. And again, I could tell this is an ellipse because when the squared terms are on the same side, they're both positive. And I could tell it's not a circle because they have different coefficients. Circles have the same coefficient for x squared and y squared. Okay, so it's going to look like you have ugly numbers, but they're actually not that bad. So what I would do to figure out the denominator, instead of doing 100 divided by 12.25, just do 12.25 divided by 100, but then make sure that goes in the denominator. All right, now do 1225 divided by 196, but then put that in the denominator. So 6.25 goes in the denominator. Now, those look like ugly numbers, but they're actually really nice numbers. Because if you take the square root of 12.25, you get 3.5. All right, so I didn't write yet that this is an ellipse. And now we have the equation in standard form. So now all I have left to do is to graph it. All right, so this is centered at 0, 0. I'm going to go left and right, the square root of 12.25. And the square root of 12.25 is 3.5. So I go left and right, 3.5. The square root of 6.25. Think about that as a fraction. 6.25 is 25 over 4. The square root of 25 over 4 is 5 over 2, or 2.5. So I go up and down 2.5. And now this is an ellipse, so I don't make the box. I just connect the 4 outside points with an ellipse. Okay, for number 5, that looks like a circle because if I move the squared terms to the same side, I see that they're both positive and they have the same coefficient. So this has to be a circle. Okay, so remember, circles don't have a 1 on the right side. With circles, you're not allowed to have a coefficient in front of x squared and y squared other than 1. So we don't like those 3's in front of x squared and y squared when it's a circle. So I'm going to go ahead and divide everything by 3. X squared plus y squared plus 2y equals 3. I left a gap to complete the square for the y's. We don't have to complete the square for the x's because there is no x to the first power term. So this would need a plus 1. Add 1 to the other side as well. So we have x squared plus factor. You get y plus 1 squared equals 4. All right, so there's the equation in standard form. They don't ask for it, but I'm going to write it down anyway. The center is 0, -1, and the radius is 2. All right, so I go to 0, -1, and I go up 2, down 2, left 2, and right 2, and I draw my circle. Okay, number 6. That looks like another ellipse. So I'm gonna put the x's together like we always do. 9x squared plus 54x plus y squared minus 6y equals -81. First we have to take out the 9 from the x terms. X squared plus 6x, leave a gap, plus y squared minus 6y, and leave another gap. All right, completing the square, we get plus 9 and plus 9 again. All right, but that's actually a plus 81 and a plus 9 for the other side. Okay, so I have 9 x plus 3 squared plus y minus 3 squared equals 9. Ellipses and hyperbolas need to have a 1 on the right side, so we divide everything by 9. All right, now these are going to cancel. So the denominator for the x plus 3 squared is going to be 1. Remember, for an ellipse, our book likes to put the bigger denominator first. So I'm going to rearrange it. And now this is clearly a vertical ellipse. So I need to write that down somewhere. This is an ellipse. Okay, so the center of our ellipse is, remember to go to the x first, -3, and then +3. And we go up and down 3, because there's a 9 underneath the y. And we go left and right, only 1, because there's a 1 underneath x. And there's our ellipse. Okay, the next set of problems are pretty easy. We don't have to do any algebra. We just have to look at it and identify it. So looking at this chart, I don't even bother with this chart. I honestly think it's way too much work. So if you want to learn it this way, that's fine. But I think it's a lot faster to just look at it, and there's a few things you can look at. So number 7, I look at number 7 and I immediately can tell it is a circle. The reason is, well, they're both squared. So because they're both squared, it's not a parabola. They're both positive, so that eliminates a hyperbola. And so it's down to circle or ellipse. They have the same coefficient. So because they have the same coefficient and they're both positive and they're both squared, it is a circle. Okay, number 8, I could tell right away because I see subtraction. One of the squared terms is positive, the other squared term is negative. As long as they're on the same side of the equation, and one's positive and one's negative, it will be a hyperbola. All right, number 9. It's not a parabola because x squared and y squared, well, they both have a square. It's not a hyperbola because they're both positive. So again, I only care about the squared terms. They're both positive. So that eliminates a hyperbola. And they have different coefficients. So that eliminates a circle. Okay, number 10. All right, they're both squared, they're both positive, and they have the same coefficient. This is a circle. Number 11, I see that the y is not squared. So because only one variable is squared, this is a parabola. All right, number 12, I see one of the squared terms is negative, one of the squared terms is positive. So because we have that subtraction, this is a hyperbola. Okay, and we have one word problem at the end. A space probe flies by a planet in a hyperbolic orbit, so we know it's a hyperbola. It reaches the vertex of its orbit at 5,0, and then travels along a path that gets closer and closer to the line. Okay, so a line that the graph gets closer and closer to, we know that is an asymptote. So we have a hyperbola, we know the asymptote. We need an equation of the hyperbola if the center is at 0, 0. So rough sketch, we know it's centered at 0, 0. We know there's a vertex at 5, 0. So because of that information, we know it opens to the right, and well, it's symmetric, so the other side opens to the left. All right, so because it's centered at the origin, And because it's horizontal, we know that we can start our equation with x squared minus y squared equals 1. We don't need parentheses because the center is 0, 0. All right, so now we just need to figure out a squared and b squared. Okay, so we know from our lesson on hyperbolas that the slope for asymptotes is either a over b or b over a. It really depends on what's underneath y. So in this case, it's horizontal. So b squared is under y. So the slope of the asymptotes is going to be b over a because it's horizontal. We know that b over a has to equal 2 over 5 based on the equation they gave. And we also know that a is in fact 5 because the vertex is 5 units from the center. So if a is 5, b has to be 2. So just be careful. Just because you know the slope doesn't mean that the numerator is b and the denominator is a. You have to just make sure that it's not a ratio that equals 2 over 5. Like it could have been 4 over 10. But in this case, it was 2 and 5. All right, so anyways, a is 5, so a squared is 25. B is 2, so b squared is 4. And we are done with this lesson.